Let's talk about artificial intelligence. For a lot of us, that phrase probably brings up images of movies like The Terminator, right? World-ending robots, that sort of thing. And, it's not just Hollywood. Some of the smartest people on the planet have given us some pretty serious warnings about it.
I mean, when someone like Stephen Hawking says that, you kind of have to stop and listen. It really creates this massive tension between these apocalyptic predictions and the AI that's already a part of our everyday lives.
Because on one hand, we imagine Skynet from the movies launching a war. But on the other hand, the AI we actually use is recommending videos on YouTube or building our Instagram feed. So what's the real story here? Is there any connection between the AI in the movies and the one that's literally in your pocket? Let's dive in.
Okay, so how do we close this gap between killer robots and helpful smartphone assistants? Well, the first step is to really get a grip on what AI actually is, beyond all the hype and the scary headlines.
So before we even get to artificial intelligence, just think about what intelligence means. It's really the ability to learn, to reason, to solve problems, and make decisions, right? Well, when a machine can do that, we call it AI. But, and this is a big but, there's a huge difference between a simple program that just follows a list of rules and a true AI that can actually learn and adapt on its own.
So, how does an AI really learn? The magic isn't about it following instructions perfectly. No, the magic is that it can get better all by itself over time. And this is where it gets really interesting.
A normal computer program is kind of stuck. If you give it something new that it wasn't programmed for, it just fails. It breaks. An AI, though, can evolve. So imagine we want to teach an AI to identify birds. The goal is for it to see a picture of a type of bird it has never seen before and still go, yep, that's a bird. How on earth does it do that?
Well, it happens through a process that's basically a simplified version of what we call supervised learning. So first, as you see in step 1, we define the features, things like having wings, feathers, a beak. Then, for step 2, the AI gives a number, a weight to each of those features to decide how important it is. Maybe at first it thinks can fly is super important. So in step 3, when it sees a penguin, its math tells it, nope, can't fly, not a bird. That's when we jump in and correct it. In response, the AI adjusts its own numbers. It might lower the importance of can fly a little bit and raise the importance of has a beak. You do this thousands and thousands of times, and its network of probabilities becomes incredibly accurate.
And this right here is probably the most crucial thing to understand. The AI has zero concept of what a bird is. It doesn't know about nests or songs or migration. To the AI, the word bird is just a label for a very complex pattern of numbers. And that's the huge difference between how an AI thinks and how you or I understand the world.
Okay, but wait a second. This idea of machine learning, it's actually been around for decades. So why is it suddenly everywhere? Why now? Well, it turns out it's because two massive changes happened at pretty much the exact same time.
First, we got a huge, and I mean huge, leap in raw computing power. And second, we created this massive ocean of data for these new powerful systems to learn from.
The computers we had back in the 90s just weren't strong enough to run these kinds of learning models. But just in the last 2 decades, processing power has gone up by several thousand times. Things that were once impossible for even a supercomputer are now handled easily by the phone in your hand.
And at the same time, the internet and social media created that ocean of data I mentioned. Every photo we've tagged, every comment we've posted, every video we've watched has become another piece of training data. We, all of us, have been feeding the machine that fueled this incredible boom in AI.
So now that we kind of get the how and the why, let's take a really quick tour of the different kinds of AI that you're probably using every single day, maybe without even thinking about it.
First, you've got natural language processing, or NLP. That's the tech that lets Siri and Alexa actually understand what you're saying. Then you have generative AI. This is the one that's been all over the news, right? ChatGPT, DALL-E, things that can create brand new text or images. And third, you've got computer vision, which is all about giving machines the ability to see. It's what powers things like facial recognition.
And these different types of AI get really powerful when you put them together. Take deepfakes. It's basically a competition. You have one generative AI working to create a fake video, while a second AI, using computer vision, is trying to spot the flaws. They go back and forth, getting better and better with every try, until the final result is, well, almost impossible to tell from the real thing.
But for all their power, these systems are not perfect. Not by a long shot. And their flaws aren't like a sci-fi villain plotting to take over the world. The real dangers are a lot more subtle, and in a lot of ways, much more immediate.
One of the biggest challenges is something called the black box problem. After an AI adjusts its internal numbers millions of times, its decision-making becomes this tangled web that's so complex, even the engineers who designed it can't fully explain why it made one choice instead of another. It's a huge deal. Here's a perfect, real-world example. Some researchers built an AI to tell the difference between pictures of dogs and wolves. It was super accurate, but it kept making this one weird mistake. It kept labeling some pictures of husky dogs as wolves. For a long time, nobody could figure out why. But when they finally managed to look inside that black box and trace its logic, the answer was completely unexpected. The AI wasn't really looking at the animal at all. It had found a shortcut. It figured out that in the training data, almost every single photo of a wolf had snow in the background. So the AI made a simple rule. If there's snow, it's a wolf. It found a pattern, but it completely missed the meaning.
And that same kind of flawed pattern matching can lead to much bigger problems. In one famous case, a company used an AI to screen job applications, but they pretty quickly realized it was automatically rejecting all female candidates. Why? It wasn't because the AI was malicious, it was just math. It was trained on the company's hiring data from the last 10 years, which already showed a bias toward hiring men. The AI just learned our own bias and applied it perfectly. It has no idea what fair or unfair means. The responsibility for catching those flaws is entirely on us.
So all of this leads us to the final and, the biggest question, the one that brings us right back to the movies. Is AI ever going to be smarter than us? And if it is, should we actually be worried?
Well, it's really important to know that every AI that exists today is what we call weak AI or narrow AI. It's designed to be amazing at one specific task. The AI from science fiction is what we call strong AI, or artificial general intelligence, a machine with the same broad, creative, adaptable intelligence as a human. And for now, that is still purely theoretical.
The real fear, the one Hawking was talking about, is the step beyond that. Artificial superintelligence, an AI that's not just as smart as a human, but way, way smarter in every possible way. On one side, you have experts who fear an intelligence explosion, an uncontrollable chain reaction where an AI starts improving itself so fast we get left in the dust. But on the other side, you have experts who say that's just science fiction, that without actual consciousness, an AI would have no reason to take over. It is a fierce debate, and nobody knows for sure.
And that brings us back to today. Maybe the real, immediate risk isn't some hypothetical robot uprising, but the very real ways that people can misuse this powerful tool right now. The challenge isn't stopping Skynet. It's making sure the AI we build reflects the best parts of us, not our blind spots and biases. So the ultimate question really isn't what the machines will do, it's what will we do with them. And that is the challenge that's going to define our future.